And today I'm going to talk about something that has been my passion for the last 2 years. So the next 25 minutes will be the condensed version of something that I've been researching, doing and thinking, and we just got to see what it is. Bring JavaScript components to the next level. So a little bit background of myself. Right now I work for Sencha. In my previous 10 years or so, I've been working on different application level programming, system programming as well, and mostly they're in not JavaScript. So it's really C++, C down to assembly and kind of hardware. So when I tried to switch to web front-end development as part of my, at that time, work on WebKit, I realized that, wow, this landscape is really fragile. Things have been improving in the last 2 years, but back then, I thought at that time that I really need to guard myself so that I don't shoot myself in the foot. So at that time, what I'm thinking is that our tools is still the level of checking your spelling. So if you see the sentence, all spelling is correct, but grammatically it doesn't make sense. Now, if you're already familiar with the comfortable and all integrated development environment, moving to that kind of environment is kind of scary. When I ask one developers what do they think about JavaScript code analysis tools, I usually phrase the questions in different ways. Like, if you want to improve the quality of your program, how would you want it to be better? So there has been tons of code metrics related to code quality, but if you just ask some, normal engineers what they want, usually it's around readability, maintainability, preventing simple mistakes, etc. That kind of thing. So I guess one of the philosophy of the tools that I really believe is that it has to have this multiplayer defense philosophy. So don't try to create something that solves 100% of the problem. It's not going to work. But it's better if one tool solves at least potentially 80%, 90%, and then it gets filtered as you go through it. Another thing is that many people think that, oh, I don't need the tools. I just launch Vim in my browser and I already create multi-billion-dollar application. That's true, but that's because you're in that area. So you have a high skill and then the complexity is probably pretty low. But as the complexity goes up, you will make mistakes. I've seen mistakes created by library authors. I've seen a framework author that makes a mistake when he's using his own framework, let alone normal JavaScript spec developers out there. So the solution is not to hire more smart people. Of course, you still need to do that. But the solution is how we can put our tools so that it increases the safety net. On the right side, what I've pictured here is that even if you're just average developer or you're getting more and more advanced in your skills, you will make less and less mistakes as the complexity of the application increases. So that's one thing that we have to keep in mind. Of course, the tools need to have some sort of feedback cycles. The JavaScript engine is a bad example of this because sometimes you write an example, you write some code, and then it comes to you unexpected token, semicolon, whatever, right? It doesn't make any sense. It doesn't give you any idea what's wrong with it. And not everyone is a JavaScript engineer. How many of you here read the ECMAScript specification? My next question is, why? You should not do that. That's a better way to learn the language. Not everyone can remember all these complicated rules and then how to typecast from one type to another and what happens if you use strict equals and etc. So it's really important that there has to be a feedback cycle from the tool itself that gives you an understanding of, oh, that's what I did wrong. And of course, right now, the state that we have is like this. So how many of you use JSLin or JSLin? So you can specify some rules, like I don't want to check for this, I don't want to check for this. But those are just explicit. That's something that you said. What if the tools itself understand what you do? What if you keep repeating the same mistake and the tool says, hey, dude, that's not right. Or you keep writing that and then removing it again. So that's something wrong. Same thing with like code style. You have to explicitly say, I want the curly braces in this position. I want how many spaces between this and this. So what if you just throw, hey, make my code looks like this. That would be like awesome. So how are we going to do this? I'm going to cover it in the next 30 minutes. Okay. So, first thing first. What is important is how we will take advantage of the parsing infrastructure. So if we look quickly at how JavaScript works in the browser, that's just one of the components. When you call the data from the server, it gets through all these pretty modules, and then finally it gets displayed through the graphics side. But the JavaScript engine is just one module of that browser environment. Of course, if you zoom in, then your code needs to be parsed, and then it needs to be passed to a virtual machine or interpreter, and then it has to get some sort of built-in object, because if you use math, strings, and so on, that's part of the runtime module. Now, the most interesting part is the parser here. So just a quick refresh. First thing, what the parser does to your code is just to split it into tokens. So if you see these famous examples, answer 42, then it identify, oh, this is a keyword, this is an identifier, this is a number, etc. When it gets that, this is sort of understanding the words in a normal sentence. This one is understanding the meaning, the semantics of the sentence. So looking at my first example, is basically declaring a variable, the answer, and with value of 42. So this is our valuable things. This is what we need to use when we build JavaScript for analysis. There has been tons of JavaScript parser written in JavaScript. I've written one, Esprima, but there has, for a while, people have been written this kind of tool. So, shameless plug, I released Esprima 1.0 today. Just because if you carefully look at the words, Empire.js shares so many letters with Esprima. Let me show you an interesting properties of a JavaScript parser. It needs to be specification compliant, because if you want to build an analyzer that works on a code, and the parser doesn't understand the specification faithfully, then something is going to be wrong there. Of course, it needs to be heavily tested. It would be really good to build a parser without testing it. And it should work in many different JavaScript environments, from browser to Node.js. And it has to create something that can be consumed to the computer as well as the human. So if you see my first examples, I stripped out the var there. This is what you get if you run it through Esprima. And this is very simple, because you can understand that there's a program there, and it's an expression, and that is an assignment, and so on and so on. So the syntax that I have chosen for this is the Spider-Man syntax, which was invented by Herman for Mozilla. And if you see, or you compare the specification and the code inside my parser, and then the syntax we produced, they are very similar. So this is very easy to understand. The ECMAScript specification, if you still remember, from the Annex A4, says that was should be like this. And if you run it through the parser, it will construct something like this, because S is just this code. And if you see the code that parses this while statement, looks like that. So it's pretty good match 1-1-1, because then you can sort of compare which one is which. Many people ask me the question, why don't you use parser generator? So the problem is that JavaScript is full of weird rules, from string mode to anything. So if you try to put some extra code to handle all those corner cases, you'll end up with larger parser than what the generator generates. So performance has to be really good. This is comparison between the previous generation and the current generation of parser. I'm not talking about only Esprima, because the new Empire.js version 2, they have the parser called Akin, they achieve pretty much the same speed. Again, one of the nice property of today's generation of parser is that you can identify which token is where. Because if you see again this examples and you see the syntax tree, you can clearly forward that, hey, range is over there. That's between the 0 and the 6 character in the code. We're going to see how this will benefit our analysis tool. For the use in IDE and editor, it has to tolerate a certain of mistakes. You might type string literals with different quotes, you might insert extra dots there, or you're still in the middle of typing, and then it has to understand what you're up to. Or with the string mode values. How many of you here use string mode fully? It needs to increase next year in Empire.js. We need to promote the use of string mode. And handling the comments, because if you create documentation tools, this will be very, very valuable. There's also a project that allows you to add comments as some sort of annotation, so you can go kind of contact us. ECMAScript 6 and Harmony, there will be talk about that, but this is basically the next generation of ECMAScript 6 or JavaScript 6, where you can use object initializer, the structuring modules and classes, and blocks. So if you want to build a modern parser, it needs to support this, or at least start to support this. Code generation is one important aspect because you want to be able to consume the code and then create a tree and then regenerate again another code, because then you can build some sort of unifier. How many of you use Empire.js? Empire.js is some sort of example of doing this. So your code is consumed, the tree is modified, and then it generates the code again that's, still function the same as the original, but it's already sorted all variables and do crazy things so that your code is shorter, much shorter. So let's see some of the tools that we can build based on this infrastructure. I generally categorize this into this couple of brackets. Let's see first the inspection, and then static analysis, transformation, and dynamic analysis. So the inspection is pretty simple. You just want to see what the code looks like. This seems trivial or useless if you're experimenting with JavaScript, but sometimes it's really helpful to try to understand what is this weird syntax, something that started to tweet some time ago. Why or what is the value of this if you execute it? One way to understand it, of course, is to plug it into the parser and see what it produces. So for me, this is just normal block statement. It has nothing to do with the expression. As you can see that this is the expression. This has an effect on it. Another thing that you can do is to build syntax validation. So the goal of syntax validation is simply to make sure that your code is syntactically correct. So does it make sense? And in other words, if you pass this validation, then it will, the JavaScript engine will not complain as it tries to parse your code. So you can run it anyway. You can build it as part of your CI system. How many of you use Jenkins? Pit City? Hudson? So it's very easy to plug your validation rules and results into any CI system. And then it gives you a feedback if something is broken. So there will be difference between running a linter and running a validator. At the current state, our linter just search for something suspicious, something that you should not do. And validator is with simpler than that. You just want to make sure, hey, is your JavaScript code valid or not. In some cases, it's also useful to validate the code that is generated. How many of you here use CoffeeScript? TypeScript? Dart? Nobody from Google? So, yeah, those tools generate JavaScript, but you need to be able to make sure that, hey, is the code valid? Because tools can have bugs as well. Or you can put it in Git pre-commit code. So before you commit something, it blocks you if something is wrong. How many of you here use Git pre-commit code? So if you're using Git, try to learn how to use Git pre-commit code because this is fantastic. Basically what it does is, it runs the script, and if it exits with certain, I think it's -1 error code or different value, then your commit will be blocked. And this is a perfect place to hook a validator. Or you can just build a code outline, because as you parse the code, and then you get the understanding of what you're trying to code here, then you can build an outline there. This is from Eclipse Orion, a JavaScript-based development environment in the cloud. Or you can build autocomplete. How many of you here use WebStorm? Okay, so WebStorm is a very nice IDE. It has a nice autocomplete, or in Microsoft Word it's called InfoSense. This is what I've been missing when I moved from C++ to web frontend, because I really like to, I don't have photographic memory, so I cannot remember everything. It would be nice if there's a hint of what I can type there, what I can run there, and what I cannot. This is from the new scripted editor from VMware's last flip source. Or you can simply highlight some part of the code. Not really visible in this projector, but if I put the cursor here, that highlights all the occurrence of that function parameter. This is very nice because when you scan code or when you do code review, you want to be able to see, hey, where this is used. You can also do some metrics or analytics on your code, like what I did here. try to find out what is the most popular keywords. So partially it's about this. And then the next one is function. So if you want to create a new language that compiles to JavaScript, tries to shorten the function from 7 letters to say 2. That saves a lot of time. You can try to analyze the statement, or you can try to find the identified distribution. So this gives you a good understanding how the engineers write the code. The longest variable names I ever met from this prototype in 7. It's very long, like 40-something character. But this is just an example because you can build all crazy code metrics there, make sure that the comments is there. What if there's a copy-paste error, and then how would you use a native function, etc. So the next one is about static analysis. This is usually very famous if you use JavaScript and JSX. You want to make sure that everyone uses strict equal, or you want to make sure that everyone not using tag. Depends on your coding style. Does everyone here have a standard coding style that you use in the team? Okay, that's good. And if you want to build that kind of check, it's really easy because all you have to do is make sure that, hey, if there's a comparison, just make sure that the operator that's used there is this and not that. So this is something that JSN or JSN can do already, but I'll just give an example here if you want to create custom tools for your team. This is my favorite, woolen trap. Can anyone guess what does false there mean? It's very hard if you don't look the API documentation. Apparently in some libraries, the slide bars can be horizontal or vertical. So you got to choose which one is which one, and that is one way to choose it. That's a very bad way because unless you look at the documentation, there's no way to figure out which one is horizontal or vertical. Well, arguably, there won't be any diagonal slide bar, so any Boolean values will be more than enough. You don't have only 2 choices. This one is even worse, especially for a non-native speaker, because instead of set hidden false, why don't you just say it's a physical true? Or if filter is not case insensitive, does that mean lowercase a equals capital A? That's always confusing. This one is the craziest one because can you guess what does this mean? Like, what is this mean? What is this mean? So probably the first one is whether you want to collapse or expand it, the items, and the second is whether you want to animate it or not. If you just look at the code or you do a code review, this is hopeless. And of course, the biggest offender is the DOM API, because anyone can decide what is the values of the So technically, we should be able to build tools that detect all those sort of wooden traps. And if you want more information, we should do that article. This is another of my favorite. This is ternary conditionals, ternary operators. How many of you use ternary operators a lot? At certain levels, things will get really messy. In my example here, it's very short, that's why it's really clear. But if you want to nest a lot of ternary operators, then be really careful, because there will be some Latin bugs. So the way to detect that is very easy, because you just see if there's an unconditional, it's a conditional, it's a conditional. You can customize how many nested conditionals you want to tolerate. Strict mode. In strict mode, this is forbidden, because you declare 2 properties of the same thing. In this 6 lines of code, very obvious, but if you have huge object literal, it's not really obvious. And in some sense, the tools need to warn you before the browser wants to go and complains about it. So a lot of static analysis tools, or at least the way it works, usually pretty much understood, because a lot of people use just in the case. So let's move to something a little bit more dynamic. How many of you here use code coverage? So what do you use? Just
JS coverage.
JS coverage? Node cover? Yeah, a lot of this code coverage, like JS coverage, that works line by line, which is okay, but not so good. Because if you have multiple statements in one line, it doesn't track that. So there's been a few projects that tries to work it based on the statement. So in this case, with your warning, because the 3rd line is not getting executed. And the way it works is that it injects a certain instrumentation in code. That's why it's called dynamic analysis. You need to run the code so that it can gather some metrics about that. So So by injecting extra statement there, it knows that a certain statement or certain expression, a certain block is executed. A promise statement coverage is not enough, because if you compare these two examples, if you see these examples and you run one unit test, you will not catch the fact that this is Q divided by Q, because it will not warn that the line is not executed. However, if you have, if I rewrite it this way, then it's obvious, because then you can see it gives a warning. This line is not executed. But if you write it this way, those two lines will be executed, so there's no really warning about that. Literally, there are two separate code branches. One returns immediately, and one goes through that expression. But if you use branch coverage, this will be obvious, because the coverage tool will tell you that, hey, that else branch there is not executed. And if you already instrument all your code, then what you can do is you can trace the execution. So here's what I did a couple of months ago. So apparently if you create an application using jQuery and then launch it, there will be like thousands of function calls. You can see the complete log in that disk. This is not necessarily a bad thing, because some of the function calls is just pretty fast and they're doing important initialization, so that's very important. However, you can put this in your CI system and tracks the progress. If one commit suddenly doubles the amount of function calls, then something is fishy. Another thing that's important to know is scalability. I've seen front-end engineers that say, oh, my function works really well because it's done in like 10 milliseconds. But if you build a contact application with RESTful, and you have only 10 contacts in your unit test or performance test, obviously it's really fast. But what if you enlarge it to 100 contacts, 1,000 contacts? How do you know the scalability? How do you know the big annotation of whatever sort of algorithm that you use? Usually it's very expensive to do formal analysis of that, so the easiest way is to instrument the code and then run your application with himself data. So like I mentioned before, increase the contact from 10 to 100 to 1,000 and so on. And the easiest way is to instrument some of the functions, like in these examples. There's an extra line inserted here, of course automatically by the tools. This line, you can log it, so you can count how many times this swap function is being called. Again, if you use bubble sort and contacts, that's really fast. Try it with 100 contacts or 1,000 contacts, then this will trigger one, because then the number of calls will increase significantly. So, transformation. Some features. One of the nice features that I like from Esprima is because it can do something that I call non-destructive partial source modification. I know that's a kind of buzzword, but what it does is that you can tell the tools to, hey, just modify this and then leave this alone. Here's quick examples. Sometimes players, team members use different quotes. Some use single quotes. Quick quote. How many use single quotes for a neutral? And double quotes? So minority. So if you need to convert it automatically, then you can use these non-destructive features. Because the tools will just look at those quotes and then change it to whatever you specify. Of course, you may need some proper scale. So it doesn't regenerate the code, it doesn't touch anything else, it's just interested only in those quotes. Again, coming back to my previous example, you can use this to format your code automatically. Because there's this nice project called Code Painter. What it does is, given a sample code, it will consume your source file and then format it. The idea is that you present nice samples with all the curly braces, white spaces, and everything as you want it to be. And then it will infer all the logic from there, including like string literal quotes, and then format your code automatically. Again, this has to be non-destructive because you don't want the code to change anything else besides white spaces and then quotes and so on. Another way to format the code or transform the code is by doing something called code regeneration. So if you have this statement and you do these 3 lines using extra tools called scode game, then you get this is the principle of tools that does unification, obfuscation, and so on. I think I got this slide. Yeah, next one. If you type this lines of code, and then you try to unify it, this is what you get. Or you can add tons of stuff to the language itself, either by modifying the language, low-level JavaScript, or Swift.js. These two are projects from Mozilla Labs. Or you can use something called transpiler, which translates future generation JavaScript into something that you can run today. So if you want to use classes, you can use a transpiler to convert a statement that doesn't run in any JavaScript environment right now to something like this, which is pretty clean and you can run it in normal browsers. As you can see, this is why it's called non-destructive, because your comments is still there. Same thing with module. If you want to use Harmony module instead of Empire.js or whatever, then you can use transpilation state. So features. What I like to have is that the tools should give us extra statistic, metrics, analytics as we review the code. Because right now, you say use pull request workflow from GitHub, it doesn't say anything about whether it passed it. It says it passed the test if you look into traffic CI. But I want a lot of integrated analytics, something from, hey, you used the wrong string quotes, or you have, for example, a scalability problem. And of course, building tools that limit the code is tedious, because you have to write lots of lines of code. What if you can use, say, CSS selector style of syntax to query the wrong assignment? That one is assignment, it should be logical tag for equals to 0. But if everyone can use declarative syntax like this, then everyone can build their own tools. Copy mistake detection. Anyone recognize the problem here? You've been partying too hard. So this one should be Y2. That was someone copies the first line, put it the second line, forget to change that. So in C++ Java world, there has been like tons of tools that allows you to detect this kind of mistakes. But we need this because I've made the kind of mistake myself. Refactoring help. If you restart the function argument, you want to change it, but you don't want to do search and replace manually because that might change something that's not supposed to be. And this is just renaming stuff, right? I want to be able to pull some segments function, put it as a inline, etc., etc. And there's a lot of things like semantic diff. If you do git diff, you just see this plain text diff, but I would like to have information, hey, you add this function, you move this variable, and so on, so on. Something that has semantic meaning. I mentioned what formatting syntax error instead of unexpected token, it should give you, hey, you forgot the for syntax is like this, and you do it that way. This is very important for all the online learning tools, which allows people to learn JavaScript, because giving a ridiculous and cryptic syntax error doesn't really help. And many other things. So, I guess the most important part of building these tools is to have modern parsing infrastructure, and this is what I've been trying to push in the last couple of months. And we've seen that a lot of people have been building that kind of tools. Well, I think for the next generation tools, we should invest a lot of effort and a lot of energy so that we can build the tools that empower experienced developers to fully reach their build perfections. And at the same time, we still allow other developers to sort of leverage the potentials of the language that we all know. Thank you.